Day 4, Problem 1. Shayla is enlarging a digital photograph on her computer. The original photo is 5 inches by 7 inches. If she enlarges the dimensions 1.5 times, what will be the perimeter and area of the new image? So Shayla has this photograph, and it's 5 inches by 7 inches. I'm going to draw a quick sketch of that. So just a rectangle, and then the width of it 5 inches, and the height of it 7 inches. And what she's doing is she's going to use her computer to transform that picture. And so here's a arrow to indicate the transformation. And what she's doing is she's enlarging it. And so let's draw a larger rectangle that's the same shape as that first one. I'm not actually trying to draw it to scale where it really is 1.5 times larger. I'm just trying to draw it larger. Okay? Now, to find the dimensions of this new larger photograph, we're told that she enlarges it 1.5 times. And so our transformation is to times by 1.5. The idea here is we can multiply these original lengths by 1.5, and that will tell us the new width and the new height. So let's do that. So to get this width here, we want to go 5 times 1.5. Okay? So 1.5 times by 5. Let's figure out what this is. 5 times 5 is 25, carry 2. 1 times 5 is 5, plus 2 is 7. The problem has 1 digit to the right of the decimal, and so if we put the decimal point here, then our answer will have 1 digit to the right of the decimal, 7.5. This is 7.5 inches across here. Okay? Now, how high is this? So let's take the height of the original photo and multiply it by 1.5. So 1.5 times by 7. Let's see what this is. 5 times 7 is 35. So write the 5 and carry 3. 1 times 7 is 7, plus 3 is 10. 1 digit to the right of the dot in the problem, and so put the dot here so that there's 1 digit to the right of the dot in the answer, 10.5. This is 10.5 inches tall. Now, once we know these dimensions, we can now answer the question. We were asked, what is the perimeter? So what is the distance around the outside of this photo? And what is the area? How much space is inside this photo? Let's do perimeter first. Perimeter, how far is it around the outside of the photo? So it is 7.5 crossed here, plus 10.5 for this side, plus 7.5 for the top, plus 10.5 for the left side. What's this add up to? 7.5 plus 10.5 is 18. 7.5 plus 10.5 is 18, and 18 plus 18 is 36 inches. Okay. Now let's get area. Well, it's 36 inches around the outside. That's what perimeter is, but area is referring to how much space does this photograph have. And to find the area of any rectangle shape, we can go length times width. And so that would be figuring out 10.5 times 7.5. That'll get us the area of our shape. So let's grab a calculator and find that value, 10.5 times 7.5. 10.5 times 7.5. Enter. 78.75. And area is measured in square inches. Now, day 4, problem 2. simplify each expression. And I see there's a question A, question B, question C, question D. And what this question is reviewing for warm-up is just some basic arithmetic kind of problems. As a senior, are you still able to work with positive and negative numbers? Are you still able to work with fractions? Those are important skills that you're going to probably still need to do later in your life. Some of the other stuff from high school math, a lot of the algebra, a lot of the geometry, unless you go into a particular career, you go into a field that's going to require that sort of math in the preparation program for college or to get the certificate, you're not going to need to know a lot of that stuff later in life. But certainly some plain old basic math is going to always be important to you in life. So let's tackle these 4 questions. Question A, negative 18, add negative 4. This is about adding numbers where they are both negative numbers. Okay? To add negative numbers together, you add the numbers. 18 and 4 is 22, and you keep the fact that they were negative numbers, so negative 22. Okay. Question B, 17 subtract negative 3. Okay. To perform a subtraction when you have negative numbers, one way to do that is to convert to an adding problem. So I'm going to convert the subtraction to adding, and I'm going to convert the negative 3 to its opposite, which is positive 3, a regular 3. So what we're doing here is that instead of having 17 subtract negative 3 and having to worry about, okay, we got all these negatives, let's rewrite this as 17 plus positive 3. Okay? That's 20. Question C, 2/5 add 1/4. Okay, here this question is adding fractions. And when you add fractions, the key concept to remember is to have the same denominator so that you're adding pieces of the whole that were cut into similar sizes. Okay, so this denominator is 5 and this denominator is 4. These are not common denominators, but we can rewrite these fractions so that they do have the same denominator. If we multiply this by 4 and its numerator by 4, that will change this first fraction from 2/5 into 8/20. 8/20 of something is equivalent to 2/5 of it. Okay? So this is equivalent to this, but just has a different form. Okay? Now let's take this second fraction and multiply its denominator by 5 and its numerator by 5. 1 times 5 is 5, and 4 times 5 is 20. And so we've changed the form of the fraction 1/4. Instead of 1/4, it's written as 5/20. They have the same value. 5/20 of something is equivalent to 1/4. It just has a different form. Now we can add these. 8/20 plus 5/20 is how many 20ths of something? 8 plus 5 is 13/20. Question D, multiplying fractions. Do you still remember how to do this? 1/2 times 18/5. 1 times 18 is 18. 2 times 5 is 10. 18/10. Okay. Now, we should simplify this, right? Because the direction said simplify. That to some people means reduce it. Maybe that word's familiar to you. 18 and 10 are both even, so they can both be divided by 2. If we divide this by 2 and divide this by 2, that will reduce the size of the numerator and reduce the size of the denominator, giving us a simpler looking fraction. 18 divided by 2 is 9, and 10 divided by 2 is 5. And so 9/5 is our answer to this multiplication problem here.